Okay. The distance an object has fallen from a still position in meters after t seconds is modeled by the equation 4.9 t squared. Okay? It says find the average velocity or slope of the secant line for the time period beginning with t equals 3 and lasting a certain number of seconds. Okay? So here's the deal. Anytime your book says average velocity, it's referring to the slope of the secant line. And in order to find a slope of a secant line, we simply use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's all we did. Part B says find the instantaneous velocity at time equals 3. So that refers to the slope of the tangent line. And to find the slope of the tangent line, we can't use 2 points. Our method has been to look where the values of the slope are approaching. So this is a part that confuses a lot of people, and I understand that sometimes reading a problem and discerning the information is difficult, but you really do need to follow this example then when you get to your book. It says this is the distance an object has fallen. What we want to do is we want to find the average velocity. How do you calculate velocity? Distance over time. So we're looking at the distance that it's fallen divided by the time. Okay? It says the distance an object has fallen is modeled by this right here. Okay? All right? And there's a certain number of seconds that have passed by. It says find the average velocity for the time period beginning with time equals 3. So it's already been falling for how many seconds? 3. And if we're going to let it fall for 1 second more, this is notation you have to be very careful with. Starts at 3 seconds, lasts to 4 seconds. Does that represent an XY coordinate? No, that represents only 3 and 4, the interval of time. Okay, this is a time interval. Okay, so these are just X values or time values. So this one starts at 3 and goes to 3.5. This one starts at 3 and goes to 3.1. Starts at 3 and goes to. So do you understand that those are not XY coordinates? That's just X values. Do we know the Y values yet? No. But what we can do, okay, what we can do is write a formula for our slope function. Okay? All right? It says for the period beginning with time equals 3. So it looks like 3 is one X value, isn't it? Okay? And 4 is another X value. Okay, X2. In fact, I'm going to change this just a little bit to make it easier. Okay? 3 would be one X value. X would be the X2 value. Do you agree? Those correspond to Y values. Okay? After the object has been falling for 3 seconds, how many feet has it fallen? How would I figure that out? 4.9 times 3 seconds squared. What does that give you? Somebody on their calculator? 24.1? 44.1. That's its position. At 3 seconds, it's fallen 44.1 feet. Or meters. I'm sorry, we're in meters. Meters and seconds. What is its position at X seconds? How many feet has it fallen at X seconds? You would simply plug in 4.9, or you would simply plug in X to your function to find out how far it has fallen. Can we now take these values, these x1, y1, x2, y2, and write a slope function? Yes, the slope would be equal to, what's y sub 2? 4.9x squared minus 44.1. So there's my slope function. I can now use that slope function to determine the slope at all those points, as opposed to finding the slope for all four of these, 1, 2, 3, 4, doing y sub 2 minus y sub 1. I can simply now plug it into my calculator. Let's do that. Go into y equals. I'm going to clear these out. And I have parentheses 4.9x squared minus 44.1 parentheses divided by x minus 3. And again, you could do this by hand. If you want to plug in 4, square it, multiply it by 4.9, and then take 4 minus 3, and you want to work it all up by hand, go ahead. Or if you want to punch in your calculator and generate the values using your table, that might be another option. Okay, so let's look at our table. What's our value starting with? What's our second x value? 4. So it looks like the velocity from 3 seconds to 4 seconds on average is 34.3 meters per second. 3.5 is my next one. So what am I doing with the x value? The x value is getting closer to, what number do I want to approach? I want to approach the number 3. I want to get close to time 3 to find out the instantaneous. 31.85. Whoop. Now I plug in 3.1, and I get 29.89 meters per second. And finally, I plug in 3.01, and I get 29.45, we'll say, 449, 29.449. So again, look at my x values. From 4 to 3.5 to 3.1 to 3.01. So I'm approaching the number 3. Look at the interval of time. 1 second, 0.5 seconds, 0.1 second, 0.01 seconds. What is the interval with approaching? What is the interval with? 0. We want to look at no time passing by. Instantaneous. So find the instantaneous velocity, no time elapsed when t equals 3. We look for where those values are approaching, and we say it is hard to know for sure. Okay, so that's a good point, is that is 3.01, is that enough? If you try 3.0001, it's like it drops to 29.4. You can? I still got 29.4. don't know. I think it's doing. I think it's doing. I think your calculator is pulling an estimation issue on us. Wow. Yeah. Well, we could. We're not going to. We could, but we're not going to. So we'll say, and if you put on your test 29.4, you put 29, put 29 point, 45, I'd accept, basically any of those. Because again, we don't know how to do it exact. We're looking for the value. I think that our calculator is pulling a trick on us. I really do. I don't know. I think your calculator is confused. Okay, so I'm going to give you a couple problems like that. We're almost out of time here. Yep, put in the same assignment. Just understand what the x and y values are. Understand what they're using interval notation and whether they're using x and y. And really try to make sure you're thinking through that, okay?